So I sent you an email earlier this week indicating that as far as preparing for the test, I was offering a test review. I would record the solutions and make them available to you so that you could listen to them at your convenience. I also said that a good way to prepare for the test is to take the practice test that I sent you. You received a copy of this already. Take it as a practice test. Give yourself the same amount of time that you will have to take the test when you come to campus or when you go to the testing center. And then use this key as a way to grade your test. That way you'll know what material you are ready to test on and what material you need to spend more time with. So let's take a look at the answers to the review test. Problem 1 says, OSU takes a random sample of 100 students from the students who purchased parking passes this year to determine how many students regularly use the campus transportation system. 43% of all students purchased parking passes this year. 23% of the sample indicated that they regularly use the campus bus to get to West Campus. So we're given some statistics about a population. The statistics came from a sample, and we're asked to identify certain aspects of this information. So what is the population in this scenario? Remember, the population is all of the individuals of interest. So the population for this scenario would be all OSU students. What is the sample in this scenario? Well, the sample is a sum of the population, particularly that part of the population from which we get our information. So we took a random sample of 100 students, and we got our information from them. We need to give a statistic from the scenario. Remember, the statistic describes the sample. So we read that 23% of the sample indicated that they regularly use the campus bus to get to West Campus. So 23% would be our statistic since it's describing the sample. And finally, we need to give a parameter for this scenario. We read in the problem, 43% of all students purchase parking passes this year. So 43% of all, that's the population. All is the key word for the population. So 43% of the population purchase parking passes, and since that number is describing the sample, then that would be our parameter. If you need help with this, you just need to go to week 1, chapter 1 material. These are the definitions that were given in chapter 1. Number 2 says the following data represent the grades earned on the first test for 20 randomly selected students. We need to make a stem and leaf graph of the data. So the stem and leaf is a technique that we learned about in chapter 2. So we're going to make the stems first, and as we scan through the data, we notice that all of the data given are in the 80s and 90s. So because the data is so concentrated, I am going to make a stem for 80 to 84, a stem for 85 to 89, a stem for 90 to 94, and a stem for 95 to 99. Now, if the data were more spread out, you wouldn't need to put in double stems for each decade. I'm only doing this because the data is so very concentrated. So now I'm going to start to record the data. 82 would look like this, a stem of 8, a leaf of 2. 96 would go in the upper 90s, 85 would go in the upper 80s, 90 would go in the lower 90s, and so on. I'm just going to go ahead and finish this. Made a little mistake there. I was in the wrong stem, so let me fix that. Now we have an 89, 94, 89, 93, and 91. So there's our stem and leaf, and what we can see from the stem and leaf is that the shape is somewhat symmetrical, with most of the scores between 85 and 94. Those are the longest stems that we have. So now we need to find the mean and standard deviation of this data, and we need to give our answers using the appropriate symbols. So in order to do that, we need to use our graphing calculator. And the first thing we're going to do is we're going to enter the data into list 1. Now I've already done that. I've listed all of this data right here. So since I have all of the data in my calculator, I'm ready to go to Stat, go over to Calc. I'm going to choose one variable, statistics. My list is in L1, so second one would give that to me if I need it. I'm going to leave the frequency list blank because this is just a set of raw data. It's not a frequency distribution that I'm using. And now I'm going to calculate. And so my mean is 89.3, and my standard deviation is 3.39 if I round to the nearest hundredth. Let's see if rounding, no rounding instructions are given, so I can round to the nearest hundredth. So 89.3 and 3.39. Now it also says to use the appropriate symbols. So this is a mean from a sample, so X bar is the appropriate symbol for that. And it's a standard deviation from a sample, so S is the appropriate symbol for that. Now I need to find the 67th percentile value. So remember, we take our percentile rank and divide it by 100, and then we multiply it by the number of values that we have in our set. So it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Looks like we have 20 values. And so I'm going to get my calculator out to help me here. 0.67, that's 67 divided by 100, times 20, gives me 13.4. So I always go to the next integer. So the 14th value in the ordered data set is going to be the 67th percentile. So in order to get the data set in order, remember I showed you how to do that. Let me move this over here if I can. Alrighty. So let me see if it'll allow me to move over here. Okay, I just want to make sure I'm in my recording screen, and it looks like I am. Alrighty. So what I need to do right here, I need to go to Stat. I need to come down to Sort Ascending, number 2. I want to sort list 1, so second one will give that instruction. I can close the parenthesis or decide not to, and the calculator will do it for me. It tells me it's done. Now when I go to Stat Edit, I can count down to the 14th item. Now notice I don't really have to count because my little information down here, right now I'm in cell 9 of list 1, and that's the value 89. So it kind of keeps track of what item I'm on down at the bottom there. So I see L1 14, that's the 14th item in L1, and it's 90. So my 67th percentile would be 90. Now I need to find the 5-number summary. So once again, I'm going to go to my calculator. I'm going to go to Stat. I'm going to go over to Calc. I'll do my 1var stats. This is all set up from before, so I'm just going to press Enter. And I want to come down to the bottom of the screen. So at the bottom of the screen, we see the 5-number summary. So it looks like 82, 88, 90, 91, and 96. And I'm just going to check that real quickly to make sure I remember those. 82, 88, 90, 91, 96. I'm good. All right, now we need to find the interquartile range, and we need to find the lower and upper boundaries, outlier boundaries. So our interquartile range is Q3 minus Q1. Q3 is 91. Q1 is 88. So my interquartile range is 3. Now my lower boundary is going to be the first quartile, 88, minus 1.5 times my interquartile range. So that's going to be 88 minus 4.5, so that's going to be 83.5. My upper boundary is going to be 91, quartile 3, plus 1.5 times the interquartile range. So it's going to be 91 plus 4.5, that's going to be 95.5. So there are my boundaries. And now I need to give any outliers, or write none if there are no outliers. So I'm looking for numbers less than 83.5. And whoops, if I'm going back to my stem and leaf plot here, I'm looking for numbers less than 83.5. 82 is less than 83.5. So 82 is an outlier. And I'm also looking for numbers that are bigger than 95.5, and it looks like there's a 96. So I have two outliers, an 82 and a 96. And the reason they're outliers is because they lie beyond the boundaries. And now I need to draw the modified box plot for these grades. And clearly mark any outliers. Remember to include an appropriate scale. So here, let's get this up again. Alrighty. So here, I'm going to let the calculator help me out here. I'm going to go to second y equals to set up my stat plot. I press enter for plot 1, and I'm going to turn it on by pressing enter. I'm going to come down and I'm going to right arrow over to the modified box plot. Now the modified box plot marks the outliers. So you can see that the first box plot has outliers marked, whereas the second box plot does not. The modified box plot marks my outliers. So I want to make sure to choose that one. My data list, my X list is L1, second 1 would give that to me if I needed to change it. My frequency is 1, and the mark that I'm going to use is that square to mark my outliers. Now, in order to see my graph, I'm going to go to Zoom, and I'm going to come down to Zoom Stat, which is number 9. Press Enter, and there is my box plot. If I press the trace key, fourth key in the top row, I can see that my box plot, the proper part of the box plot, begins at 84, goes to 88, there's the median at 90, that splits the box in two, goes to 91, and then it stops at 94. Then I have outliers at 96 and 82. So I'm going to translate that here. I'm just giving myself a scale. And I've got an outlier at 82. I have an outlier at 96. My box began at 84. I'm sorry, my box plot began at 84. And the whisker, or the box that goes between the quartiles, starts at 88, split in half at 90, ends at 91. So 88 to 91, splits in half at 90, not quite in half, but into two parts. And then it goes up to, I'm just going to go back and pick up that last non-outlier value, which is 94. So it's going to come up here to 94. And there is my box plot. This information was covered, the box plot was covered in Chapter 3 along with the percentiles and statistics. So it's in Chapter 3. Now we're moving on to Chapter 4 and number 3 here. Donato's completed a marketing study to determine what types of pizza people liked. They offered one free slice to each of 1,000 people and recorded their age and whether they took triple cheese, meat lover, or veggie. The following summarizes the results. So we see here broken out by age, young people from under 13 to 21, and then the adults. We're calling adults anyone from age 22 to 80. And a person is randomly selected. Answer the questions that follow. First, you will need to find the marginal totals. Give your answer in fraction form on the first line and in decimal form on the second line. So we're going to need to find our marginal totals first. So I'm going to add down the columns. So I'm going to use my calculator to help me here. 230 plus 120 plus 50 gives me 400. Now, I can save myself a little time. I know we handed these pieces of pizza out to 1,000. The problem told me that, 1,000 individuals. So if there are 400 young people, there must have been 600 adults. And you can double check those numbers on your calculator if you like. Now I'm going to find the row totals. So 230 plus 190, 420. Oops. So it looks like we've got, well, I'm going to get there. 420 plus, and I'm going to do, all right, I'm going to do it this way. We have 420. It's easier to add 120 and 210 in my head than it is on that calculator. So it looks like we've got 330. And 50 plus 200 is 250. I'm just going to add those three numbers together and make sure that I've done my arithmetic correctly. I'm sorry, my calculator does not want to, my computer does not want to behave today. So let me see if I can get this out here. All right, just trying to see what I wrote down. 420. Plus 330 plus 250. And I don't know why my calculator is so darn touchy. But let me go back and fix these. We get 1,000. All that just to make sure that we've got it right. Well, we do, thank heavens. So now we're ready to get started. What is the probability that the person is a young person? Well, there were 400 young people out of the 1,000 that we gave pieces of pizza to, and 400 divided by 1,000 is 0.4. What is the probability that the person prefers veggie pizza? Well, there were 250 people who preferred veggie out of the 1,000, and in decimal form, that's going to be 0.25. What is the probability that the person is a young person and prefers veggie pizza? So young people are in the first column, veggie pizza is in the third row. So it looks like those 50 individuals were young people and preferred veggie pizza. And so when we put that in decimal form, we get 0.05. And let me get down a little further here. What is the probability that a person does not prefer meat pizza? Well, now the way I would do this is I would take 1 minus the probability that the person does prefer meat pizza. There were 330 individuals out of the 1,000 who preferred meat pizza. So 1 minus 330 is going to be 670. Let me correct that. Divided by 1,000, and that gives me 0.67 as a decimal. And let me just move this over here. Good. Looks like we've got that centered now. So let me come down here. What is the probability that the person prefers cheese pizza or veggie pizza? So remember, when we see or, we have to add. So there were 420 who preferred cheese, 250 who preferred veggie. So our probability is going to be 420 over 1,000 plus 250 over 1,000. And when I add those together, I'll get 670 over 1,000. And that's going to be 0.67 as a decimal. What is the probability that the person prefers cheese pizza and veggie pizza? Well, everybody got 1 piece of pizza, not 2. And there were, your choices were cheese, veggie, or meat. So no person got both veggie pizza and cheese pizza. So that's impossible. And when things are impossible, that means 0 out of the 1,000 people fell into that category. And so our probability is 0. What is the probability that the person is an adult or prefers meat pizza? So we have to go back and look at our table. We had 600 adults, and we had 330 who preferred meat pizza. So we've got 600 adults, and then we have 330 who prefer meat pizza. And of course, when we see the word or, we add. But now we double counted some people here. There were 210 adults who preferred meat pizza. 210 is in the 330. 210 is part of the 600. So we have to take the 210 out. We counted it twice. So we have to take out one of those double counts. And so it looks like we have, 720. If we add those all together and subtract the 210 out of 1,000, so that's going to be 0.72 as a decimal. Given that if the person is a young person, what is the probability that he or she prefers veggie? So we know for a fact that it's a young person. So our population for purposes of this problem will be just the 400 young people. And of the 400 young people, 50 of them preferred veggie. So 50 divided by 400 will be our probability in unreduced fraction form. And I'm going to get the calculator to help me out here. 0.125 is the decimal form of that. Given that the person prefers veggie pizza, what is the probability that he or she is a young person? So we need to come back here. And it looks like, for purposes of this problem, we're given that they prefer veggie pizza. So our population is going to be that 250. And of those 250 individuals who preferred veggie pizza, 50 of them were young people. So it's going to be 50 over 250. That's 1/5. That's 2/10. So that's going to be 0.20 for my probability. Now we need to name two events in the table that are mutually exclusive. Well, you can name any two, but right here we were given two events that were mutually exclusive. Remember, we said that nobody preferred cheese and veggie. They had to choose one. So cheese pizza, veggie pizza, and we could say prefers, so we know what we're talking about. That would be one of many correct answers. Young person and adult would be two mutually exclusive events. Prefers meat pizza, prefers cheese pizza would be another example. I think you get the idea of what those mutually exclusive events look like. And Kay says, use the results from previous parts and either the multiplication rule or conditional probabilities to determine whether age and pizza preference are independent or dependent events. And we need to explain our response. So this is a problem that you did in the group work for week 3 when we were studying chapter 4. You had this very same problem with a different set of numbers. So you've seen this before. So I'm going to take a look, and it looks like I've got some information on a young person and the probability that he or she prefers veggie pizza. I could use either H or I in this problem. I highlighted H, so I'm going to use it. So given that the person is a young person, so we have the probability that they are a young person. Given that they're a young person, what is the probability that he or she prefers veggie pizza? And we know that that's 0.25, 125. If these are independent, then the probability that a person prefers veggie pizza, given that they're a young person, should be the very same as the probability of veggie pizza. That's the definition of independence. If they're independent, these two probabilities are the same. If they're not independent or dependent, then these two probabilities are different. So what's the probability that the person prefers veggie pizza? Well, let's see if we've got that. Yeah, in part B, what is the probability that the person prefers veggie pizza? That's 0.25. So now I know what that is. Well, 0.125 does not equal 0.25 or 0.250, so that would be a not equal to. So it looks like these are dependent. So age and pizza preference are dependent. Since the probability that a person prefers veggie pizza, given that they're a young person, is not the same as the probability that a person prefers a veggie pizza. And finally, L, which problem illustrates the complement of an event? Well, we use the complement rule up here on part D. Part D, we use the complement rule to, oops, let me get that out of there so no one is confused. There we go. So part D, we use the complement rule to figure that out. And so it looks like part D represents the complement of an event. All right, so moving on to number 4. Number 4 says the following data represents the ages of applicants for jobs posted by Franklin University. So we had 13 individuals, applicants who were in their 20s, 27 who were in their 30s, 23 who were in their 40s, and 11 who were in their 50s. We need to complete the frequency distribution given above, and then we need to approximate the mean age of the applicants and the standard deviation. So it looks like we had a total of 10, 14, carry a 1, 2, 4, 6, 7. It looks like we had a total of 74 applicants. Just added those together. And the midpoint, we would find the midpoints by, we would find the midpoints by using our formula. So remember the midpoint formula? We learned about this in chapter 3 during week 2. The midpoint formula is the sum of the lower limits divided by 2. So our first midpoint is going to be 20 plus 30 divided by 2. So I'm just going to put this here. That's our first midpoint. The lower limit of the first class plus the lower limit of the second class divided by 2. And of course that's going to give us 25. So my midpoint for the first class is 25. Now I can use the class width to find the rest of the midpoints. Notice that the difference between the lower limits is 10. 20 plus 10 is 30, 30 plus 10 is 40, 40 plus 10 is 50. So my midpoints will also be separated by 10. So 25 plus 10 is 35. 35 plus 10 is 45, 45 plus 10 is 55. Now I need to approximate the age of the mean age of the applicants and the standard deviation. So in order to do that, I need to use my calculator. So I'm going to go to Stat Edit, and you'll see in list 2, I entered the midpoints. In list 3, I entered the frequencies. You'll need to do that. And you can use any lists you want to put these in. Just remember where you've put them. Once you have your midpoints in one list and your frequencies in the other, you're ready to calculate the statistics. In order to do that, you need to go to Stat, go over to Calc, choose one var statistics. The midpoints are in list 2. The midpoints are your X list or your data list. There are frequencies for these midpoints, and they happen to be in list 3. So second 3, whoops, sorry about that. Second 3 will give us our frequency list, and now we're ready to calculate. So it looks like our mean age for the applicants is 38.58, and the standard deviation is 8.38. And if it asks me to use proper symbols, here would be the proper symbols. And so there's my answer. In number 5, we're working with chapter 4. In number 5, we studied that in week 3. That was the last chapter that's on this test. So we have a bowl of 50 M&M candies in there, and there are 6 yellow, 14 brown, 10 blue, 5 orange, 9 red, and 6 green candies in this bowl. What is the probability that you randomly select a brown candy? Well, there are 14 brown candies out of the 50, and you can write that as a fraction, you can write that as a decimal, or you could write that as a percent. Just follow the instructions given on the test. What is the probability that the second candy you randomly select will be red if you do not replace the first candy? Well, the first candy we selected was brown. So it looks like there are 9 red left in the bowl, but there are only 49 candies left because a brown candy is sitting on the table. That was our first selection. Part C says, what is the probability that the second candy you randomly select will be red if you do not replace the first candy? Or sorry, if you do replace the first candy. So the first candy we selected was brown. That means there are 9 red candies in the bowl, but since we replaced that first candy, there are 50 candies in the bowl that we're selecting from. So you see that selecting with replacement and selecting without replacement give us different probabilities, very slightly different. So if we looked at the decimal for 9 divided by 49, we would get 0.184. And if we get the decimal for 9 over 50, we get 0.180. So there's a slight difference. When you're doing these problems, you will be instructed to write the fraction that you're using to get the probability, and usually we ask you to convert that to a decimal, so use your calculator to help you with that. Finally, what is the probability that you select orange, then a green candy? If you sample without replacement. So I've got just a couple of corrections to make here. That should be if, and no and needs to be in there. So we need an orange, then a green, and we are selecting without replacement. So to get an orange candy, looks like there are 5 orange candies of the 50 candies that are in the bowl. Then a green, that means we need to multiply. Then a green candy, so we're doing it without replacement. So since we selected an orange candy first, there are still 6 green candies in the bowl, but there are only 49 candies left. So it looks like we've got 30, and I'm going to get the calculator to help me with, I'm going to get the calculator to help me with the other. It was 50 times 49, 2450. And if we wanted to find the decimal form for that, 30 divided by 2450 is going to give us 0.012. And you might be asked if this is an unusual event. And of course here we would have to say yes, since our probability, 0.012, is less than 0.050. So if you're asked that question, we practice that quite a bit in week 3. So just make sure you remember what unusual is. Unusual is any probability that is less than 0.05. We would say the event is unusual. So part E says, what is the probability that you select a blue candy, then a yellow candy if you select, if you sample with replacement. So we need a blue candy, then a yellow candy. So it looks like we have 10 blue candies out of the 50 times. Then we need a yellow candy, but we replaced the blue candy before we selected the yellow candy. So there are 6 yellow candies out of the 50 that are in the bowl. So it looks like we have 60 over 2,500. And if we wanted the decimal for that, .024. All right, so again, some Chapter 4 probabilities. The last questions that we're going to work on, we're going to go back to Chapter 1 and work with some of the definitions there. So first thing we're going to do in exercises 6 through 9, we need to identify the kind of sample that is described. So website ratings. A popular website is interested in conducting a survey of 400 visitors to the site in such a way that 200 of them will be under the age of 30, 150 will be aged 30 to 55, and 50 will be over the age of 55. So of course what we have here is a stratified sample. We're selecting some people from each of these 3 strata. Number 7 is about a favorite performer. Viewers of a television show are asked to vote for their favorite performer by sending a text message to the show. This is that notorious voluntary response. Sample. Does not give us good data if we're going to use it to try to get an estimate for a parameter of a population. 8 is about school days. A researcher selects 4 of 12 high schools in a certain region and surveys all the administrative staff members in each school about a potential change in the ordering of supplies. Which type of sample does this represent? That's a definition or an example, of our cluster sampling technique. There were 12 clusters, 12 high schools. The researcher selected 4 of those, and then surveyed all of the administrative staff members in each of these selected schools. Political polling. A pollster obtains a list of registered voters and uses a computer random number generator to choose 100 of them to ask which candidates they prefer in an upcoming election. That is the example of the simple random sample. Remember, the simple random sample is like pulling names out of a hat. Although we use technology to help us, we use random numbered tables on our computers to help us with that. So those are the sampling methods. Make sure you review them and are able to identify examples from those. The last 2, well, no, I take that back. The next 2 problems that we're working on also come from Chapter 1, and they're about the types of studies that we learned about in Section 4 of Chapter 1. So we have cell phones and driving. To determine whether using a cell phone while driving increases the risk of an accident, a researcher examines accident reports to obtain data about the number of accidents in which a driver was talking on the cell phone. So first of all, we need to identify what type of study this is. Is it a randomized experiment or is it an observational study? It happens to be an observational study. The researcher is simply observing what happened in these accidents, which happened prior to the researcher's inquiry into this question. In a randomized experiment, the researcher would randomly assign the treatments to the individuals. Here, the participants chose the treatments, which is to talk on the cell phone while you're driving, or do not talk on the cell phone while you're driving. That was chosen by the drivers, the participants. So this is an observational study. Assume that the accident reports show that people were more likely to have an accident while talking on the cell phone. Could this result be due to confounding? Explain. So absolutely, this could be due to confounding, because that is a problem with observational studies. So the confounding that could take place, there are lurking variables that are also at play here that we're not studying. To name a number of them, or to name a few of them. Location of the accident. So New York City, Washington, D.C., L.A., San Francisco, those huge cities. You've got the congestion. So that's what I mean by location. So the congestion of traffic is going to be a factor here. The experience of the driver is a factor in an accident. I should say of driver. Another thing would be the time at which the accident occurred. Is it rush hour or not rush hour? Again, there's congestion there. Another one might be conditions, weather conditions. Weather conditions are often contributing factors. And, the list could go on and on and on. So lurking variables could explain the accident. And so since we're not studying these lurking variables, we can't say for sure that it was using the cell phone that caused the accident. Another study was done with homework. The English department at a local college is considering using electronic-based assignment submission in its English composition classes. To study its effect, each section of the class is divided into two groups at random. In one group, assignments are submitted by turning them in to the professor on paper. In the other group, assignments are submitted electronically. Is this a randomized experiment or an observational study? Well, this is an example of a randomized experiment because the treatments to turn the assignment in on paper or to turn it in on the computer were randomly assigned to the participants, to the students. Assume that the electronically submitted assignments had fewer typographical errors on average than the ones submitted on paper. Could this result be due to confounding? Explain. And here, in a randomized experiment, we take care of confounding. So this result could not be due to confounding. Since the treatments were randomly assigned, all lurking variables are present in both groups. So anything we see in any difference we see in a randomized experiment can be explained by the difference of the treatments. And finally, we're going to slip back or go forward, I guess, into Chapter 3 to review some position statistics called z-scores. And we're also going to review the empirical rule there as well. So assume that the histogram of starting salaries is approximately bell-shaped. Approximately what percentage of the salaries will be between 34,860 and 40,280? And we're going to draw the curve to show our work. So here I need to give you some information. So let me do just a little bit of work here. When I wrote this problem, it looks like I left some things out. So let me see what I've got here. Oops. All right, so let me see. I've got 34,680, 4,280. So it looks like our mean is, oh, wait a minute. $74.90 divided by 2, 37,480. and our standard deviation is equal to 1400. All right, that information was left out. I do apologize. I took these examples from the chapter reviews in your textbook, and apparently there was some information given before these problems that I failed to capture. So we've got it now. So assume that the histogram of starting salaries is approximately bell-shaped. Approximately what percentage of the salaries will be between 34,680 and 4280? We need to draw the curve. So we've got an approximately bell-shaped data, and we're going from 34,680 all the way up to 40,280. And we want to know what percentage. So remember, with the empirical rule, which is what we're working with here, we need to first of all find out how many standard deviations. We call that K. So I'm going to take 40,280, and I'm going to subtract the mean from it. The mean is 37,480. And when I do that, looks like I get 2,800. Now, a standard deviation is equal to 1,400. So I'm going to divide that distance, that difference, by the standard deviation. And 2,800 divided by 1,400 is 2. So K is equal to 2. So now I have to think back to the empirical rule. The empirical rule says that approximately 95% of all the data lie within 2 standard deviations of the mean. So our answer here would be approximately 95%. As I said earlier, this is in Chapter 3, the material that we covered in Week 2. 13 says, assume it is not known whether the histogram of starting salaries is bell-shaped. Fill in the blanks. At least blank percent of the salaries will be between 34,680 and 40,280. So here, ignore this instruction. We don't need to draw the curve to show our work. We just need to find the percentage if the salaries are not bell-shaped. Well, this is Chebyshev's theorem right here. Same section of Chapter 3. And Chebyshev's theorem says at least 1 minus 1 over k squared of the data lie within k standard deviations of the mean. We already know that k is 2. From our previous work. Same mean, same standard deviation, same limits for the interval. So 1 minus 1 over 2 squared is 1 minus 1/4. 1 minus 1/4 is 3/4. 3/4 is 75%. So at least 75% of the data would lie over this interval if the salaries were not bell-shaped. The last question, you also need to be able to find z-scores and compare them if necessary. Here we don't have to do any comparisons, but we do need to find the z-score. Again, this is in Week 2, Chapter 3. Let me see if I can get this pen to show up. All right. So John's starting salary is $38,180. What is the z-score for his salary? So remember, the z-score is going to be the value minus the mean divided by the standard deviation. So the value of his salary is $38,180. The mean for the salaries is 37,480. And the standard deviation of the salaries was given as 1,400. So I put this on my calculator. I get a difference of 700 divided by 1400. It looks like his z-score is 0.5. So John's starting salary is 1/2 of a standard deviation above the mean salary for all employees. Hope your studying goes well. I wish you much luck on the test. Make sure that you take your calculator. Make sure that you take your formula sheet in your own handwriting. Make sure you turn the formula sheet into your proctor so it can be submitted with your test. You will get the formula card that is given with this review in addition to your own formula sheet. Study well, prepare hard, and I wish everyone the best of luck on the test.